Hello everyone. So in this part of the video, I'm going to show you how to use DataRobot for forecasting in maritime scenarios. Okay, so by now it is expected that you have seen all the regression videos and the exponential smoothing and the basic concepts in forecasting videos, and you know how to play with them. Okay, and here today I'm going to show you how to run your data for forecast in the DataRobot tool. So the DataRobot, actually, this is a kind of whole new stream. It includes a whole new stream of models and applications and ways of doing forecasting and analytical and analytics. Okay, and the DataRobot, actually, it is kind of known as a automated machine learning platform. So here we're using some simple kind of click here and there. You can actually run a whole bunch of automated machine learning models, which will give you some forecast results. Okay, so but now the thing is, here we can learn about DataRobot in many courses. They already have something called DataRobot University. They have many courses there. I have taken a couple of courses which last for quite long, many hours actually. So I'm going to explain you this in 15-20 minutes. So I'm not going to cover everything. I'm going to show you how it works and get you introduced with this tool, and you can then play with it. Okay. If you go to DataRobot University, you will find more material there if you're really interested in it. So go there, look into it. But for now, when you log into DataRobot, so you go to DataRobot, app.datarobot.com, you log in here, you will find this user interface, and then here you can load your file. So I'm going to load a file. This file I will provide to you as well, so which called forecasting data. So I'm just going to quickly open it to show you how it looks like. So as you can see, it looks like this, similar to the data that you have seen in the previous videos. Okay, so it starts from 1996, and here we have until 1999. Okay, December, and here we have 5 variables, and this is our main variable of interest. Okay, cap worry rates. Okay, and these are the periods that we would like to forecast. Okay, so now let's say we are going to load this data. Maybe one good idea would be actually to remove this part of the data from the data set. Okay, but I'm just going to load it now so you can play with it. Okay, so I'm just going to load it as it is now. So here you see, when we load the data, DataRobots run some analysis. And here you can actually increase the number of users. So we have virtual workers for our project. So I increased it to 4. Okay. So I believe you also have 4. So increase it to 4. So you see, when in DataRobot, we upload some data, it runs some analysis itself. Okay. So it does the raw reading of the data, does some exploratory analysis, which we can see here if we scroll down. So we can see the mean, median, standard deviation, and all this information here for all the variables. Based on the date, it also kind of extracted the date into 3 components. Okay, so it has like day of the month, date, month, day of the week, and year. So it actually extracted the date. So from only the date, it extracted 3 new variables. Okay, so this is how it looks like. And here you see it says that you have some quality issues. This data has outliers. Here also it says this data has outliers. Okay, so you see it runs some nice exploratory analysis quickly. You don't have to do anything, any coding or anything. You just loaded the data. So that is cool, right? Here you can actually run the name of the variable that you want to forecast, but also we can do it from here. So let's say we are going to forecast cap worry rates. We say use these as target. So these will be forecasted. And here we can see how the data looks like. Okay, this data, cap worry rates. Now this is a time series data. So we have to tell it that this is a time series data. We go set up time series. And it already tells you that they detected something. So we say, okay, yes, use date as our time series component. Okay. So here they have two options, time series modeling and out of time validation. But now we are going to use the time series models. Okay. So just select this one. And here you can see actually how the data looks like. Okay. So when we are in time series modeling, then here we have to tell these two things. What will be our forecast window and what will be our feature derivation window. So after this part, actually, what DataRobot will do is something called feature engineering. Okay. So I will show you quickly how it looks like. But so first, let me define like how many previous time periods should it consider for feature engineering. I'm going to set it to 12. You can play with different values and see how it works. So I'm just trying to cover one full year. Okay, so 12. And then here, forecast window. How many time periods in the future that you would like to forecast? Would you like to forecast only 1 month? You can also forecast more than 1 month. So let's say I'm setting it to 6 months. Okay. Great. Here we have one option called features known in advance. So if there are some variables of which data we already know in advance, then we can actually select them here. Okay. But for now, let's say, no, we don't know anything in advance. Okay. So we know the data of the same year at the same time. We don't know for any of the variables, the future values of the data. So we don't know anything in advance. Okay. Also, we have an option here for calendar. So here we can actually set up a calendar for holidays and things like that. So if I quickly click here, it will take me here. So if I have Excel file with dates and dates of the calendar, holidays and things like that, I can actually upload it, the Excel file or CSV file. Alternatively, you can actually generate a calendar as well. So you click here and you set one of the country. So for example, for us in this data, China or Brazil would be interesting. Okay. But I'm also not going to do this. You can play with it and see how it works. So I go up and I go hide advanced options, and this is how it looks like. Okay. So actually, if we want, we can already run some forecasting. But before doing so, let's say we go show advanced option. We will go to this tool here called partitioning. So in this partitioning, we have to select the time windows for backtest and validation. Okay. So in time series, these are two things that we often care about. So here, as you can see, we have 2 backtest and 1 holdout period. So here, holdout period is like the test sample. So if you have watched the previous videos, we have the training sample and the test sample. So here, the holdout period is the test sample. Okay, it is kind of the final test sample. Okay, so here, this is our holdout period. But then we actually also have 2 more periods for training. Okay, so the blue part is the backtest part. So this part of the data will be used as a training to forecast this green part here. Then this part of the data will be used as training data to forecast this green part here. Then this part of the data will be used to forecast this part of the holdout period, which is the last stage of forecasting. So this is like this software allows you to do actually multiple level of training and test sample forecasting. Okay. You would like to have even more number of holdout periods. You can just go here and increase your number. You can make it 4 if you want. Okay. So this is how it looks like, right? But now let's keep it simple. Let's keep it to 2. You can play with them, these holdout periods. So the idea of this backtesting is that, if your forecast model performs very well only in this part of the data, and suddenly the time series is very different in this part, and your forecast, the selected model from this part may not work very well in this part. Okay, so That's why we partition the data in multiple series so that we can capture the model which works best in different types of the data, in different parts of the data. So on overall level, which model works the best? So we can capture that. So that's the idea actually of this backtesting here, right? So let's say we keep these things like these. We don't do anything else. We can do many more things, but let's say we just keep it like this. And here you have three options. Here you have the autopilot, which will run quite a lot of models. You have the quick. So autopilot runs about, I think, 200 models or something like that. And the quick one runs about like 50, 60 models, something like that. And the manual here, you can see in DataRobot, they have a large repository of models. So in the manual, you can go there and pick the models that you would like to apply. Okay. But for demonstration purpose, I'm going for quick. You can play with it with autopilot and manual later, which is recommended, especially for the assignment. You should play with different combinations and find out better solutions. And this is what we will try to see in actually the group presentation, which group had the better forecast performance and how they did it. Okay, so this is something we'd like to see. So we go for quick, and I'm just going to click run. So now you see it starts to derive features. Okay, so this part is called the feature engineering part. So you will see based on the data, it will actually create many variables, okay, based on the properties of data that might have an effect on the future date, the future of the variable that we are trying to forecast. Okay, so you see, for example, here the forecast distance, new variable created, the difference of 6 months median, 12 months mean, 12 months mean, naive latest value. So all these are created based on feature engineering. Okay. Actually, it creates many variables, but in that, it also leaves out some of them which does not have a significant effect. And then keeps only the ones in the modeling which has a significant effect. Okay, and you can see here our time series modeling is going on. Okay, so it may take a minute, not a minute actually, a bit more than a minute. So I'm going to pause the video and I'm going to run it again when all these processes are done. Okay, so I'm just going to pause the video. Okay, so now we see that it has been running quite a lot of models, and we also see that it has generated quite a lot of variables as we have seen before. And here the green bar actually tells us which of the variables has the most importance, okay, in this forecasting the Cape what if rates. Okay, so you can see the larger the green bar, the higher the effect of that variable. And here are our models are running. And here, if I click here, actually, you can see that it ran so far 9 models. So if I go here, I can see actually all the models. And here we have the root mean squared error, but I would like to actually see the MAPE. So that's more interesting to me, as I have mentioned before. Okay, so based on MAPE, then I actually see it's still running some models, okay? And I see that actually this non-seasonal AutoML, this is one of the most best performing models, okay? So when it's running some more models, I can just click here and I can see how this model works. So if you click on the model, it gives you the blueprint, okay? The process of the model, how did it work? Okay, and if you want to see some more information, if you click on evaluate, then actually you will get some more information here. How did the model work? Okay, for the backtest 1, you can change to backtest 2, and you can change to all backtest. You can see how did the model work. So here we can see the actual values and predicted values. Okay, and here we can actually increase the months and see when it was making a 1 month forecast or 6 month forecast, how did it change? So you see when it was making a 6 month ahead forecast, the forecast were not very good for this period at least. Okay. Yeah. For here, it was rather okay. Here it was okay. Here it was, yeah, okay. Okay. We can change it to all back tests to computed. So for these two back tests, how does it look like? Okay, for the back testing periods. So here you may wonder, why are we getting actually these 4 time periods? So if you go back to the partition, you will see that for the forecasting, we had actually, so we used training sample in the backtest, but we left like about 4 time periods on the for training sample. So that's why we actually see these 4 periods. Okay. And if you click in understand, then it will kind of give you the feature impact, which variables has the highest effect. So if I click here, it has been queued for creating. So it takes some time for this computation. But at the same time, we see that there is one model going on called AVG Blender. So the Blender models are the ones where we combine multiple models. Okay. So that is something really cool. And DataRobot generates some Blender by default, but you can actually also create your own blenders. I will show you quickly how to do that. But let's just have a quick look in these features, how it looks like. Okay. So here, one of the things is, there are so much more. So here, actually, I see that the date is actually the most important one. Okay. From the original features, the date is the most important one. From the derived feature, also date is the most important one that has an effect. Okay. So that's interesting. And we are actually using AutoReMA. So AutoReMA is autoregressive model where the previous values of the variable affects itself. Okay. Anyway, so I'm not going to discuss this detail about this model, but this model I know very well because I've been using it many times. So that's why I mentioned a little bit. But now, if we go back to our models again, now we see we ran 12 models. Okay. And it shows that this is one of the, these are the 3 best models. So sometimes you can also pick them. Actually, you can put a star. Okay, this is the best model. This is the best model. And you can, instead of the star, I clicked somewhere else. And this is the best model. Okay. So this same model, although you don't see any information here, you will find it just here. If I look into M31 BP59, it should be just here. M39, yeah, this is the model. Okay. So although it has higher error in the backtest 1, but in all backtest it had, actually it still had high compared to the AutoReMA and average blender. Actually, the average blender is the best one. So if you click here on the average blender, it will show you the blueprint, how actually it works. Okay, so this is how this average blender works. So you can create your own blenders, as I mentioned before. Okay, so to do that, what you do is let's say if you select 2 models. So let's say if I select this model and this model. Okay, if I select these 2 models, then I go to menu. Okay, then I go for blending, and then I go for, but there are a few options for blending. You can pick any one of them. So then you will have a blend model. So let's say, if I just click this one. So the blending is going on and it will show up soon when it's done. Okay. So this is also one more thing I would like you to try, to try different combination of blending and find out if you can beat the robot, So that would be really cool. If your blend or your way of doing this thing can actually beat the robot. So if that would have better performance, lower MAPE, So the robot is cool, but maybe with our help, we can do more with the robot than it can do itself, right? So anyway, it is going on. But now let's say if I'm going to show you quickly how the prediction looks like, and then we finish. Okay. So let's say I pick one of the model and then I want to make some forecast. So I'm going for predict. So now, okay, it says that we haven't tried the model on holdout data. So we should unlock and run the model on the holdout data and see how it works. Actually, based on the data as I have put here, my holdout data is what I have put here, right? So my holdout data is part of the training sample, is part of the test sample, my holdout data, right? But anyway, I can see my performance for my holdout data. So there I see the MAP is actually quite high, 40. Okay, so that's quite high. But anyway, so just to show you how this prediction thing works, to do prediction, you have to import a file from your local file. Okay, so here I have prepared a local file, which I call forecast predict. So if I open, I can show you how it looks like. So you see, this is how it should look like. So for these periods, I am keeping my target variable empty. Okay, I'm keeping my target variable empty so that I can get the forecast values. Okay, so this one we will use later, 4.5.48 we will use later, but now let's say we just keep up to this point and I save it and I close it. And then I'm loading it here. It takes like 10-15 seconds to run it. Great, so now it ran the forecast. Here we can say compute predictions. And it is almost done. And now it's done. So I'm just going to download my forecast. And if I open this file, then I think I should see 6 forecasts. Yeah, this is my prediction here now. And I see that this is my predicted value and it's all same, okay, for all these periods. But I will count only this one here, okay, for 1999 July. This is the forecast I will be counting. To get the one for August, what I will do is I will then go to import file and local file. And let's say if I go to my predict data and I put one more data point here, okay. I will try to put this 5.48, one more data point here and save. And then I will load it again, okay. And then you will see the forecast for the next period. So I'm closing it here. I have shown you how to run your data, how to get the models, how to combine models, and what is the best performing model, and then how to actually make predictions using the best performing model, okay? And in this process, you also know to do this cross-validation back testing, okay, for different parts of the data. So this is really a cool tool for forecast because, you know, it runs so many models at once. Normally just modeling, like if I do a lot of modelings using R, but then it takes me like many days to code like 3-4 models. And here you see we ran like 14 models in like 20 minutes. So that's the power of this DataRobot. So here is the value for August. So that would be the predicted value. And then if I want for September, I would again just put the value of August in the data set and then load it here for prediction again. Okay. So thank you for listening. I hope you find it very exciting. Okay. Try to run your models, play with it. Okay. If you go to their website, you will find some tutorials there as well. So play with it and apply it in your assignment, and then we will see how it works in the presentation. Okay. Bye-bye.